cancel the x from here, and leave this as a plus 100 over x. So it'll look like this, negative 0.01x plus 40 plus 100 over x. That's the way they do it. It's not customary to do that for other problems. I mean, specific to this problem, you would actually cancel in that manner. Wow, I just had some weird deja vu. Alright, whatever. It happens all the time, because I see the future.
Because of math?
No, I have dreams.
Of what?
You don't want to know. Of things, but they're like a long time, like, it'll be years sometimes. But then the thing will happen, I remember having that dream. Anybody else have this experience? Come on, fess up.
I don't dream anything.
What's that?
My mind's empty when I
had
sleep.
A feeling. Well, it's not a feeling. I know I dreamt it. I know something has transpired at that moment, meaning with me, not like somewhere else in the world. Something I'm doing, and I know I dreamt about it 6 months ago. Yeah?
Yeah, that's happened.
Lee?
I've never.
It's because I was
Never.
in your winter class, that's why.
Could be.
I have a question.
Justin, yeah.
So how come when you cancel out the x squared, the 40x, but why'd you keep the 100 over x?
That's just the way the book cancels these things. I'm just trying to take the x from each piece. But here it doesn't have an x to take from. So I'm left with an x underneath there. Here I can take away one of these and take away this one, but this one's stuck with it.
Okay.
And you would not simplify it like this in any other case.
Okay.
It's only to represent the average cost function. Because this helps tell you something about what happens as x gets larger. Okay. Okay, so the marginal cost function is going to be given by our C prime. It's called the marginal cost function, but it's really an approximation. C prime of x, okay, what's the derivative? Where's the thing? I lost it. There it is. Written down to 2, so negative 0.02x plus 40, right? Don't differentiate the average cost. That's not what we're doing. We're differentiating the original.
Where'd you get the negative? Oh, the x squared.
Yeah, the original one. Go back to the original one, yeah. That was part A. B, determine the average and marginal cost when x equals 1,000. Okay, that's not very good. Determine average and marginal cost when x equals 1 grand. You're producing 1,000 items. Just plug numbers in. So C bar at 1,000 is going to be what? What's 0.01 times 1,000? 10? So negative 10 plus 40 plus a 10. C prime at 1,000 is going to be, what's 0.02 times 1,000? 2? Negative 2 plus 40. And then you crush numbers, you have 30 plus a 10, it's 301 on 10. Is that right? We'll write back as 30 and a 10. I think it's more telling about the problem. We're talking about production. 30 and a 10. It's okay. Mixed numbers are okay too, right? All right, and negative 2 plus 40 is 38. Now, what are the units? This you got to be careful with. Units. So for the average cost, it's going to be, remember the original is just dollars, cost per, right?
Dollars over items.
Dollars over items. That's right, dollars per item. So dollars, say it was in thousands. Didn't say anything like that. Okay. So dollar per item. It's dollar per widget. Okay? Dollar per widget. So what's that? $30.10?
$30.10.
Right, $30.10.
110.
So when you're producing, what does it say? When you're producing 1,000 items, each one is costing you to produce about $30.10. Each one is around that, right? On average. So you have this thing. What are its units? No different. Same units, but it just means something different, right? So this is also dollars per widget, per item, whatever you want to call it. Why? It's a derivative. We have the notation dc dx. dc is the cost, and x is items. So cost per item, same thing. So what does that one tell you?
Is that cost per item about the thousand item produced?
If you were producing 1,000 items,
That would be the thousandth cost of making
If
that
you made
product.
1,000 items, that's how much it would cost to make those 1,000
Yeah.
items.
no, that's what this function. That's what the original is.
I'm at that point. When that thousand is at that point, so as
If-
soon as
yeah,
you make
if
that
you were
last
pro-
thousand, at that point, that would be your cost for making that.
You're saying for this one.
No, the bottom.
Second one?
Yeah.
This is going to be the approximate cost of making the next one.
Oh, making that. Okay.
To make the 1,001st object, it's going to cost you about $38. That's what the marginal cost is telling you. So what you see is, if you're making 1,000, then on average, each one costs you about $30.10. But to make that next one, it's going to cost you about $8 more to make that next one than regular, right?
So if you wanted to figure out the thousand, you would type in 999 for that.
If you want to know the cost of making the 1,000th item,
Yeah.
you would do C prime at $9.99. That's
Yeah.
correct.
Okay.
That's right. Okay. If you want to know the cost of making the x plus first, C prime at x. Always one down. The derivative is one down for the approximation. Interpret the values obtained in part B. We just did. Right? We just interpreted those values. Any questions about the interpretation?